All right. Hey guys, how's it going? So, this is going to be us learning how to balance redox reactions. Um, this can be, it's a process. Yeah, not gonna lie, it's a process. But it's a good process. It's a good process. So, you guys yesterday we learned how to identify um, the reduction step and the oxidation step of each of these redox reactions. So the first thing you want to do is figure that out and then write the half reactions. So those two reactions that we found, the reductions part and then the oxidation part, separate them. Okay, they're two different things. We need to separate what's giving up the electrons and what is taking in the electrons. That's step one. So figure out what's being reduced, what's being oxidized, separate those two. All right. Then we need to go through and balance everything except oxygen and hydrogen. Usually we want to save those for last anyway, but let's balance everything but those guys, and then stop. Okay, that's step two. Step three, the way we're going to balance both of these equations for oxygen is if we have oxygen, we're going to add H2O. All of these redox reactions are typically going to be done in water. So there's going to be plenty of water around. We can add it. We can make it. It's not going to really do much. So, let's add water to whatever side we need to balance out the oxygens. All right. Then at that point, we're probably going to have to just deal with the hydrogens. Then the hydrogens, we need to balance out the hydrogens by adding H+, because this is going to be done in an acidic solution. Usually we want to do things in an acidic solution. Like I said, that most redox reactions are kind of like electricity, right? You're moving electrons around. Think battery acid. We want to do this in an acidic solution. You can do it in a basic solution. We'll get to doing that later on. But this is in a acidic solution. So we're going to balance hydrogen by a whole bunch of H pluses all around. Then balance our charge with electrons. We're going to add in E minus to balance the charge of our equations. And then we're going to have two equations, and maybe let's say we have two equations here, and we got a bunch of stuff on either side. Blah, 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 blah. Maybe on this side, we are bringing in 3 electrons. That's what we had to do to balance it, the charge. And on this side, we're doing 2 electrons. We are giving up 2 electrons, and this one's taking in 3 electrons. Now, here's the thing. We need to put these guys back together. And we know that however many electrons are being given up are being taken up by the other step, right? So whatever is being oxidized and is losing electrons, something is being reduced and gaining the same number of electrons. You can't just have electrons just flying around. So what do? We have to balance these guys. So in order to do that, we need to make sure that however many electrons are going out is going to be the same number going in. All right. So you kind of just have to think, all right, I'm going to have to multiply this entire thing by 3 to get 6 electrons coming out. And I need to multiply this top one by 2 to get 6 electrons going in. And so that means I am going to have to go through with all of these coefficients, multiply by 3 up here, multiply these coefficients by 2. So that is going to be the thing. And then combine these reactions back together. An example is probably going to be nice. So let's go through and do that example. All right, this is what I have here, this example. So first things first, what's being oxidized, what's being reduced? So let's go through and think about this. Iodine here is a free element, so it's 0. This is going to be 1 minus. So already we can tell that this thing is gaining electrons, so it is being reduced. That is going to be our first reaction. This is probably going to be oxidized, so let's take a look at it and see. All right, so oxygen's 2 minus. There's 3 of them, so that's 6 minus. 6 minus. We need something. 6 minus to get to 2 minus. That means this is going to be 4 plus. 4 plus 6 minus equals 2 minus. And that means this 4 plus is split between 2 things. So 2 plus. Awesome. So we're something going from, the sulfur is going from 2 plus to 2 minus. There's 6 of them. So that's 12 minus. So this is going to have to be 10 plus. 10 plus divided by 4. Did I do that right? Yeah, no, that's right. Divided by 4 is 10 doesn't divide by 4. It's going to be like 3.5 plus. Did I mess up somewhere? 10 plus negative 12 is negative 2. Yeah. 10 minus 12 is 2. Negative 2. Yeah. Okay. Yeah. So, but anyways, you can still see that this thing is losing electrons. So this is going to be our oxidation step. All right. Great. So let's split up our things. All right. So we're going to have iodine going to an iodide ion. Okay. And then we're going to have disulfur trioxide ion going to tetrasulfide or tetrasulfur hexoxide 2 minus. All right. So there we go. Awesome. So this is our yeah. Okay. So this is our separate reactions here. Okay. Great. Awesome. Now the first thing we want to do now is balance everything. Let me switch to a different color. We're going to want to balance everything but the oxygens and hydrogens. No hydrogens to speak of, so it's going to be easy. First one, we need to balance this guy. We need 2 iodide ions to make this balanced. Cool. Here, we need to balance these guys. It's going to be a pretty easy balance. And there we go. There's that. Great. Now, what? Next step is going to be to balance oxygens with H2Os. Cool. Well, we don't really need to do that. The oxygens are already balanced here. Cool. We're done with that. Then we're going to do the same thing. No hydrogens to speak of, so we don't need to balance anything there. Great. Now we are needing to go through and balance charge. And by balance charge, I mean, if we look here, there's 2 negative charges on this side, and this side is neutral, so we have to balance that out. So we are going to be adding 2 electrons on this side. Okay. Here we have 2 minus 2. So we have a total of 4 minus on this side and 2 minus on this side. So to balance that out, we're going to need to put 2 electrons on this side. Great. Now, let's go through and add these boys together. When you're adding things together, you do a, same thing we've been doing for a while. If it's on like net ionic equations, if it's on both sides of the equation, you can mark them out. So these 2 electrons are both crossed out. Everything else can go. So on the reactant side, we have 2 S2O3 2 minus plus iodine goes to S4O6 6 2 minus plus 2 iodides. Now, you might be thinking to yourself, well, hey there, this is pretty much the exact same thing as before. I didn't have to do all of these steps. I could have just looked at this and been like, yeah, just a 2 there and a 2 there, and I'm good. It's true. Yep, that is perfectly true. Here's the thing, though. You didn't know if these electrons would have worked out unless you've done all these steps. So, let's go through and do something else that is, maybe a little bit more, complicated. This is going to be our next example. This one's going to be a little bit more complicated, but we're just going to do the exact same steps as before. So first step, we need to figure out what's being oxidized, what's being reduced. So unfortunately, we don't have any straight elements to do, but that's not bad. It's not too bad. So 2 minus for this oxygen, that means 2 times 3 is 6 minus, which means we need 6 plus, which means this is 3 plus. Here, 2 minus. 2 minus 3 is 6 minus. We need 5 plus to get this whole thing negative. So 5 plus on the nitrogen. Here, 2 minus and 1 plus means that this is going to be 8 minus and 3 plus, which means we need 5 plus. So this becomes 5 plus. And then 2 minus, and this would be 2 plus. All right. So we have that now. Awesome. What is being reduced? What is being oxidized? Here we go. So we have something being going from a 3 plus to a 5 plus. So it is losing charge, negative charges. So this is the oxidation. And the nitrogen here is becoming a 5 plus to a 2 plus. So we are gaining negative charges here. So this is being reduced. Okay. So now we have ourselves the half reactions. I'm going to change this up, rewrite this. So one thing I like to do is kind of draw a line on my reactions, because this can be sometimes can be a little confusing. So we know that this, so I like to keep my reactants and products separate. Okay, so this is going to be the nitrate going to the nitrogen monoxide, and the other thing is going to be AS2O3 H3 ASO4. All right, so there we go. Now we have this split up. So we've separated into our half reactions, the reduction and the oxidation. Now, the next step is we need to balance these things except for oxygen and hydrogen. I'm going to change this up to, let's go blue. The reduction step, nothing needs to go. Nitrogen and nitrogen, we're good. Here, AS2, this is AS, so this needs to be 2. Great. Now, next step is water. Let's go back to, let's make it purple. So now we need to go through and add water to things to balance out oxygens. We have 3 oxygens on this side, 1 on this side, so we need to add 2 H2Os to this side. Here we have, what, 8 oxygens on this side, 3 on this side. So that means on over here we're going to need to add, what, 5 H2Os. All right. Now, switch up my colors again. We're going to do the H plus, the hydrogen ion step. So we need to balance these things according to their hydrogen ions. So we have 4 hydrogens on this side, none on this side. So we need H plus, and this is going to be 4 of them. All right, here we have 10 hydrogens, and over here we only have 6. So that means we need to add, 10, 6, yeah, 4 hydrogen ions on this side. Great. So now I'm going to go with kind of a light blue. There we go. Now we're going to balance charge. Okay, so on the top reaction, the reduction, over on this side, we have 4 plus, 1 minus, so it's 3 plus. And over on this side, we have 0 plus, or it's completely neutral. So where are the negative charges going to go? Remember, we can only add negative charges. So over on this side we have 3 plus, this side we have neutral. Well, that means we're going to have to add electrons on this side. We need 3 of them. So now we have neutral and neutral. And here we have neutral on this side and 4 pluses on this side, which means we need to add 4 electrons to this side. Okay, now the fun part. Switch to red. All right, so now we have 3 and 4. Ah, geez, okay. So how are we going to get 3 and 4? What can we do? What can we multiply each of these by to get each of them to be the same number? One easy way to do it is just do 3 times 4. So 3 times 4, or if we multiply everything here by 4 and we multiply everything on this reduction one, this bottom one, by 3, the electrons will work out. So now I'm gonna erase and rewrite all of this. So 4 times 3, this is going to be 12. 4 times 4 is going to be, 4 times 3, it's not 12. Wait, 4 times 3. Yeah, 12. 4 times 4 is 16. 4 times 1 is 4. 4 times 1 is 4. 4 times 2 is 8. Sorry, I had a little brain fart. And then here, 3 times 5 is 15. 3 times 1 is 3. 3 times 2 is 6. 3 times 4 is 12. And 3 times 4 is 12. All right, excellent. So now we have that step. Now the next step is to combine these guys. So we combine them together. All right. So we're going to have to combine these guys together. I'm going to switch to black. All right. So we're going to need to cancel things out. So is there anything we can cancel out? We have 12 electrons on this side, 12 on this side. So those are going to cancel. You're always going to cancel those out. Hydrogens. We have 16 on this side and 12 on this side. So that means I'm going to cancel 12 out, and this is going to turn to 4 hydrogen ions on this side. Okay. H2Os, we have 8 on this side, 15 on this side. Whoop. $15 on this side, so 8 minus 15 is 7. So we have 7 on the here. And I think that's all we can cancel out. Great. So now we just need to go through and add these together. Okay, kind of smoosh them together. So we're going to get 4H plus 7 H2O plus 4 nitrates plus 3 AS2O3, and that is going to make 4 nitrogen monoxides plus 6 H3ASO4. And there is your balanced reaction. Yeah. So, one thing you can kind of tell from this is a couple of things. Some of these redox reactions are going to change the pH of things. So, with this, this is both the redox reaction, but it is also a acid-base reaction because we are losing hydrogen ions. So the pH is going to start to go up because we are decreasing hydrogen ions as this reaction goes forward. Yeah, there's going to be some weird things going there. But that is essentially what you're doing. This is a kind of a bigger example which uses all of these the rules and the steps. Okay. Hopefully that works for you guys. One thing it's always going to be good to do is to just double check yourself that you everything works out. So 7 times 2 is 14 hydrogens plus 4. So we have 18 hydrogens over here. 6 times 3 is 18 hydrogens. Great. Awesome. 7 oxygens plus 12 oxygens plus 9 oxygens. 7 plus 12 plus 9 is 28. 28. And over here we have 4 plus 6 times 4 is 24. 28. Yeah. So oxygens are balanced. We have 3 AS, or 6 AS and 6 AS, and 4 nitrogens, 4 nitrogens. Okay. Yep. So all the elements have balanced out. Great. Hooray. All right. So this is those are some of the examples you can do. Just remember to go through these steps. Write the half reactions. Balance the atoms, except oxygen and hydrogen. Then balance oxygen by adding H2O to the other side. Then balance hydrogen by adding hydrogen ions to the other side. Then balance charge using electrons. So if it's if one side's positive, the other's neutral, add the electrons to even it out. And then make the electrons equal by multiplying the whole reaction and add the half reactions together, kind of like a net ionic equation. All right, that's that. So, great. I have some practice problems. They're not huge. Here they are. I'm just going to want to give you these first 7. Okay. Make sure to underline the, well, okay. Let me talk about this real quick. You don't need to know this for the AP exam. The AP exam does not like the word oxidizing agent or reducing agent. Those are some terms. I mentioned before, like how you add negative charges, and then reducing seems like it's small, but it's gaining electrons. Well, this adds another layer on top of that, because an oxidizing agent is the thing that's doing the oxidizing, not the thing that is being oxidized. So the thing that's being oxidized is losing electrons. The oxidizing agent is being reduced. Yeah, exactly. So don't worry about the underlining the oxidizing agent. The one thing you can think about is if it says oxidizing agent, cross it out and just put the thing being reduced. Reduced. So what's being reduced? All right. Yep. So I'm going to give you this worksheet. I would totally suggest rewriting this and balancing it on a separate sheet of paper. There is no way that you can do all of the work in such a tiny space. So go through, rewrite it, do that, and yep, do that. All right, guys, I will see you guys on Monday. Have a good one.